Hey guys, how's it going? Mr. D here. So today we are shifting gears a little bit and we're starting a brand new chapter for our algebra unit. So we are going to be actually looking at chapter 2, which is on graphing linear equations. Alright, now in order to do that, we first have to establish a few ground terminology as well as a few key features of coordinate planes and graphing. So let's go ahead and get started right away. Alright, so just going to scroll down here for a second. Alright, so our coordinate plane consists of a y-axis and an x-axis. Alright, now those two meet at the very center, which is something we call the, whoops, sorry about that, something we call the origin. Okay, so those are just a few keywords here that we're going to need to know in order to plot a few points down and reach our objective. So actually, let's go down here to our definition of an ordered pair. So an ordered pair is just the location of a point on the on the coordinate plane. This ordered pair is comprised of an x value and a y value. Okay, x always goes first, y goes second. All right, and now when we're talking about the origin and where our x coordinates fall according to that origin, we say that starting at that origin, use x to move right, okay, which actually is in the positive direction, okay, and we go left, which would be in the negative direction. So if we have any negative values, we would be going to the left on the x-axis. Now our y-axis moves up and down, so we have up, so we have a plus, and down, minus. So once again, if I have a positive number, I'm going to be going up in my y-axis. If I have a negative number, I'll be going down. Okay, good. So now we have an idea of what an ordered pair is, and we're going to apply that in just a second. But before we do that, let's go ahead and get an idea of our coordinate plane and how we can divide that coordinate plane into a few quadrants. So starting with this top right-hand corner, I'm going to label this Q1. Quadrant 1. Okay, so that is quadrant 1, and we label the rest of those quadrants as we go counterclockwise. So quadrant 1 is upper right, so quadrant 2 is upper left. Okay, next we have quadrant 3, so go ahead and write down a Q3, and finally quadrant 4. Okay, good. So now let's just make sure we understand what we meant by the shifts from the origin on the x and y axis. So we said that if we move to the right, we're going in the positive direction. So if I'm going over here to the right, which this quadrant 1 is in, I'm going to have a positive x-axis. However, I also go up on my y-axis from the origin, so my y is also going to have a positive value. Okay? All right, as we look at quadrant 2, well, I'm also going up, so this is going to be a positive on my y, but for our x value now, we're actually going left, and we said earlier that left means minus, so that's going to have a minus or a negative x value. Okay, now for quadrant 3, we're going left and down, which means we're going to go left, which is negative, and then down, which is also another negative. So you're going to end up with two negative numbers for that particular order pair if it falls in the third quadrant. And then finally, for quadrant 4, it's to the right and down from our origin. So it's going to be positive and then negative. So positive value for your x and negative value for your y. All right. So let's go ahead and use that in order to identify a few ordered pairs in this next problem. All right, so 1 through 10 say, write the ordered pairs that correspond to each of the following points. Okay, so we see all of our points on our on our coordinate plane. So let's go ahead and write the ordered pairs for all 5 of the first problems. All right, so let's take a look at point A. So for point A, starting at the origin, always start there. Try to get to point A. We want to end up here. So once again, we always have our x value first, then our y value. So first I have to go left and right, and then up or down. Okay, so x-axis, so I go left and right. So let's see, which way do I have to go? Well, I have to go right. So I'm going to go right 1, 2, 3, 4, 5, 6, 7. So positive 7 because I went to the right 7. And I'm also going up 1. Okay? So because I went up 1, that means I have a positive y value of 1. And that's it. We've officially written down our first order pair. So just make sure that whenever you're not provided these parentheses that you see right here, guys, that you always make sure to write them in. Okay? So if you weren't provided that parentheses or those commas separating that ordered pair, make sure you always write those in. Okay, guys? All right. So that was A. So point A. Now let's go ahead and find point B. So I'm going to use a different color now. So starting at the origin, I want to get to B. So I'm going to go 1, 2, 3 to the left, which is, again, left means negative. So I'm going to write a negative 3. And I'm actually going to go 1, 2, 3, 4 up. So a positive 4. All right. Hopefully starting to make a little bit more sense. But let's go ahead and keep going. Now we're looking for point C. So I'm going to go ahead and do that in orange here. So again, always left and right first, then up and down. So 1, 2, 3, 4, 5, 6 to the right. So I'm going to write a 6. And then I actually go 1, 2, 3, 4 down. So in this case, I have a negative 4. All right. Good. So let's actually go ahead. I'm actually going to go ahead and erase some of these lines just so we don't get confused here. And I'm actually going to try out letter D. So now, once again, start at your origin. We want to get down here to D. So first, left and right. So in this case, I have to go, whoops, sorry about that. In this case, I have to go left. So I go 1, whoops. Sorry about that, guys. Not sure why that happened. All right, there we go. So we have to go left 2. So 1, 2. So a negative 2. Oh, I'm sorry. We actually only just had to go 1. I was looking at the letter D, not that coordinate. I'm sorry about that. Let me go ahead and erase that real quick. Let's try that again. So starting at the origin, I'm going to go left just 1. Okay, so I'm going to go just 1 space left. So that's a negative 1. And I'm also going to go down 1, 2, 3, 4, 5 spaces down. So negative 5 down. Okay. And finally, let's go ahead and take a look at letter E. So once again, start at your origin. In this case, E is to the left side. It's in the third quadrant. So I'm actually going to go left. So 1, 2, 3, 4, 5, 6, 7, 8. So I went negative 8 and down 1. All right, good. So now, again, guys, you have 2 methods of doing this here. You can go back up here to our definition of an ordered pair, and you can think, are you moving on the x first? Okay, so we're either going to be moving left or right first, so a positive or a negative value. Then you're going to be moving on the y, so it's going to be up for positive and down for negative. So just go ahead and count just like we did, all those values and which direction you're going on. Now, if you are a little bit confused as to why one of them has to be a positive, one a negative, you can always use this quadrant chart here that we have on the right hand side. So if something falls in the first quadrant, like let's say A fell in the first quadrant, that's why I have two positive y values. I'm sorry, two positive x and y values, okay? So notice it's a positive 7 and a positive 1. So that's why I have two positive values, because I'm in the first quadrant. All right. Now let's go ahead and take a look at another example. Let's say, for example, point C. Point C was in the fourth quadrant, according to our quadrant chart, which means that I should have a positive x value and a negative y value. So let's double check that. Do I have a positive x value and a negative y value? Yes, I do. Okay, so that's another way you could double check your work, guys. All right, so what I want you guys to do right now is for numbers 6 through 10, so points F through J. I want you guys to, I'm sorry, F through J. I want you guys to actually pause the video, try it out on your own, write your ordered pairs, and then we'll come back to double check if you did it correctly. All right, guys, let's go ahead and take a look at a few of these problems. So for number 6, we're looking for F. So once again, always start at the origin. Okay, now F looks like it falls in the second quadrant, so I know right away that I'm going to have a negative x value and a positive y value according to my chart up top. But again, we can also count and get to that F. Excuse me. So I'm going left 1, 2, 3, 4, 5, 6 values to the left, which is negative. So negative 6. And I'm going up 1, 2, 3, 4 values up. Okay. Point G. Well, point G here, once again, starting at the origin, I'm only going to the right 2. So I only have a positive 2 here, and it actually doesn't fall in a quadrant. It falls directly on the x-axis. And you guys will start to notice later on, as we continue working with graphs, that anything on the x-axis actually has a y value of 0. We are not moving up or down at all. All I did was move to the right 2. So because I did not move up or down at all, my y coordinate is just 0. All right. So let's keep that going. So now point H, it's all the way up here. So the ordered pair H is all the way up there. Now again, it's in the first quadrant, so we know we're going to have two positive x and y values. All right, but let's go ahead and count them out. So I want to get to the to the H. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So I'm going positive 8. And then I go up, so 1, 2, 3, 4, 5, 6, 7. So I go up 7. All right, good. So hopefully you guys have those so far so good. I'm going to go ahead and actually erase this so we don't get too cluttered here. All right, let me use red now. So point I is all the way here on the left side in quadrant 3. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 to the left. So negative 9. And I'm also going to drop twice, so negative 2 for my y value. And then finally, we are looking for point J. So we go 1, 2, 3, 4, 5 to the right, and down 1, 2, 3, 4, 5 down. Okay, so a positive 5 and a negative 5. So positive x and a negative y, just like we were told up here for our quadrant 4 order pairs. Okay. All right. So hopefully that started to make a little bit more sense. If for some reason something does not make sense so far, guys, make sure to stop the video for a second, go back to something I talked about earlier, and make sure it understands before you guys proceed, okay? I want you guys to make sure you understand this fully before we move on. All right. So for number 11 through 17, what are we doing? So we're trying to plot each of the following points and state which quadrant they fall on. Okay, so let's go ahead and plot the order pair 3, -5, which is point K. Let's go ahead and do that. So 3, so starting at the origin, I'm going to go positive 3, 1, 2, 3. Remember, x-axis first. Left and right always first, then up and down. Okay, so I went to the right 3, and then I have a -5 for my y value, so I'm actually going to go down 1, 2, 3, 4, 5. So I have my point K. All right, good. Now I want to find out, well, what quadrant does that fall on? Well, let's go ahead and make sure we remember our quadrants. This upper right-hand one is quadrant 1, quadrant 2, so we're going counterclockwise, quadrant 3, and quadrant 4. All right, so what quadrant did we fall on? We fell in quadrant 4. Okay, good. So now let's go ahead and do point L. So I'm going to go -4. Again, remember, guys, x-axis first, then y. So left and right first, then up and down. So -4, it go -1, 2, 3, 4. So I'm somewhere right here. And then I'm actually going to go up 1. So you should have this labeled as point L. All right. So again, if you need to, go ahead and draw your little counting marks. So I went to the left 1, 2, 3, 4, and then I went up 1. If you need to draw those, that's totally fine. Go ahead and do that. If you don't need to, then you don't have to. All you have to do is plot each of the points. Okay? All right, so that one falls in quadrant. It looks like here, like it falls in quadrant 2. I'm gonna write quadrant 2. Okay, now you can use the Roman numerals or you can actually use numbers. That's totally fine. So if you wrote Q2, whoops, sorry about that. If you wrote Q2 or quadrant 2 like that, that's either of those is totally fine. This is more conventional. You'll probably see that more often than not. Okay, so next one is point M. So we have 7, 2. So let's go ahead and do this in a different color. So 7. So 1, 2, 3, 4, 5, 6, 7 to the right and up 2. So it should be somewhere right there. Always make sure you label it if you're being asked to label it. So this one now falls in quadrant 1. All right. Good. Let's keep going. Now, the next one, we have point N. It's at 0, -8, which means we are not moving left or right at all from the origin. So I am starting here. So I don't move left and right at all, but I do have to move down -8. So 1, 2, 3, 4, 5, 6, 7, 8. Right down there is my point N. So now, what is it asking? It's asking what quadrant is that in? Well, does it actually fall in a quadrant? Doesn't it actually look like it falls between quadrant 3 and quadrant 4, but it's not actually in one of the quadrants? Okay, that's because it's directly on the y-axis. So if you ever have something that falls directly on the x or y-axis, then you just state that. So you would say point N is on the y-axis, not necessarily on any other quadrant. So it's okay to cross that off and say it actually falls on the y-axis. All right, let's go ahead and continue. Let's try to keep using different colors so we don't mess these up. So point O is -6. So 1, 2, 3, 4, 5, 6, 7, 8, 9 to the left. Okay, and then down 6. So somewhere around here, and then down 6. 1, 2, 3, 4, 5, 6. Should be somewhere right there. Hopefully you guys got the same thing. All right, and keep going, guys. Move on ahead if you feel like you feel comfortable with this already. All right, next one we have point P. So 2 to the right and down 8. So you should be somewhere right there. Okay. So, and then finally point Q is 5, 1. So let's go ahead and use a different color there. So 5, so 1, 2, 3, 4, 5 to the right and then up 1. So this last one is point Q. So I actually went ahead and graphed all those points or plotted all those points for you guys, but now you guys have to decide what quadrants those fall on. Okay, so go ahead and pause the video for a second and tell me what quadrants point O, P, and Q fall on. Alright guys, so point O we see here on the bottom left hand side, so that actually falls on quadrant 3. Alright, point P is on the bottom right hand quadrant, so that one actually is in quadrant 4. And finally, point Q is on the top right, which means it's actually in quadrant 1. Alright, so it looks like all these points had a quadrant that they belonged to. The only one that was a little different was this one right here, number 14 for point N, which only asked us to go down 8 values from the origin. So because it did that, there was no left and right shift, so we were directly on the y-axis. Okay? Alright, let's go ahead and keep going. Alright, so this last little bit of notes, we have what are called relations. Okay? So all we have to know about relations is that a relation shows the relationship between the x and y values. Okay, so that's all a relation is, and we'll talk a little bit more about it as we continue with these notes. But for now, we have to write a few other definitions here for domain and range, which go along with relation. Now, the domain of a relation is all of the x values. Okay, and the range is all of the y values. All right, so when you have a relation, so if you're going to have something like few ordered pairs, and then they're going to ask you what the relation is, I'm sorry, what the domain of that relation is, then you would just tell me all of the x values, and then for range, you would just tell me all of the y values. All right, so another way, and just to clarify this here a little bit more, because I'm going to use a certain notation in a second, you can also say this is the set of all x values, and this is the set of all y values. Okay, now the reason why I'm mentioning that is because we're going to write some notation in a second that's called set notation. So just keep that in the back of your mind now. All right. Then finally here on the side we have something that's called a function. And all a function really is a relation, like we just talked about, but with a few more restrictions or a few more criteria. We say that a function must have a set of unique domain values. Okay? And the x values must never repeat. So if we do have a relation that never repeats on the x values, then we are probably looking at something that is considered a function. Okay? Now, on a graph, the relation must pass something called the vertical line test. And all that test really is proving this here, that the function has unique domain values and that they never repeat. Okay, so let's go ahead and talk a little bit about graphing these points given the input and output values, or the domain and range values. Okay, and then we'll actually talk about what are those domain and range values and whether or not the following relation will actually be a function. Okay, so let's take a look at the input values, or rather, let's look at these as ordered pairs. I think that'll be an easier way of looking at things. Okay, so all of this really is, guys, is an ordered pair. So the first ordered pair that I have here is -10, comma 9. Okay, so I'm going to go -10 on my x, so left and right. So go all the way -10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and I'm going to go up 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So my first ordered pair, or my first point, is up there. Now I'm going to do -7, -2. So 1, 2, 3, 4, 5, 6, 7 to the left and down 2. Here's my second order pair. Then I do -1 to the left, 1, but I don't go up or down, so I actually stay right on the x-axis. Then I do 0, 6, which means 0 left and right, but I do go up 6, so I should be somewhere up here. And finally, we have 7, 6, which is 1, 2, 3, 4, 5, 6, 7, and up 6. So just remember, guys, real quick, you're always starting here. You're always starting at the origin before you start counting any of your values. Okay. Now, I did mention something a little bit earlier that I hope you guys start to remember. Input values, which you see here on the left side. So let me actually go ahead and highlight that. So input values are just your x values, okay? But we talked about what all the x values are, right? We said up here, if I scoot up real quick, that all of the x values, or the set of x values, is my domain. So input has another word that we just learned, which is domain. So these are all my domain values, which means my output are all my y values. But again, we just talked about what output is. I'm sorry, what y values were. Whoops. I did not mean to do that. Sorry about that, guys. All of the y values is what's called the range. So right here is the range. All right, good. So let's go ahead and identify then what our domain and range is. All right, so in this relation, which is basically just these 5 order pairs, we have a set of domain values. So the set of domain values are all of the x values, just like we talked about. So let's go ahead and write those down. So this is where set notation comes in handy. So what I want you guys to do is start off by drawing a little squiggly bracket. Okay? Now, what I want you guys to do is take all your x values and go from least to greatest. So write down the smallest of the x values. So in this case, the smallest I see right away is a -10. I'm going to separate them by a comma. So next one I see is a -7. Next smallest is a -1. Next is a 0. And finally a 7. And I'm actually going to end it with another squiggly bracket. Again, this right here, guys, these little bars right here are showing us a set. This is called set notation. Alright, so whenever you see those squiggly brackets around a few numbers like that, we're looking at a set of values. In this case, a set of domain or x values. Alright, now for output or the range values, again, I have to, whoops, that was a pretty bad squiggly bracket. I'm not the best at those. So if you can do them better than I can, more power to you. Alright, so the range values, we have, let's see, what's the smallest one? We have a -2, because that's the only negative there. The next one I see is 0. Now, the next one, actually, we have a repeat on. So we have a repeat for my range values. Keep that in mind. I have a repeat in my range values. So I actually don't have to rewrite it twice. I'm just going to write it once. And then finally, I'm going to end with my 9. Okay? So try to do your squiggly brackets as best as possible. They should look something like this. I'll try to do them slow. So you guys get a better idea of what they should look like. And even those are pretty bad compared to what they should look like. But if you can get anywhere remotely near this right here, guys, you guys are in good shape. Mine look pretty bad, but it's alright. So the next thing is this relation a function? So you guys have to think about that. The way we found out whether or not this is a function, I'm going to scoot up for a second. It says a function must have a set of unique domain values. In other words, the x values must never repeat. So let's look. Our domain values, so my x values here, did they repeat? Did -10 repeat? Did -7 repeat? No. -1, 0, 7. No, none of them repeated. So because none of them repeated, I can tell you right away that yes, this relation is a function because there are no repeats in my x values. Or you could also say, yes, it is a function because all of the x values are unique. Or you can actually now, since we did graph all of these points, you can tell me that you used the vertical line test. Remember, it says up here, on a graph, the relation must pass the vertical line test. So let's actually test this out. So if you went using that approach, let me draw a vertical line right here. Again, bad line, but you guys get the idea. So if I draw a straight vertical line through that point, did it cross any other points except for that one point right here? No, it only crossed one point. So that's passing the vertical line test. Now, if I draw another one here, did it hit more than one point? Nope, just hit that point. Same thing here. So anytime I draw a vertical line around any of these points in our relation, okay, we always just end up hitting one time, okay? And because it only hits one time, then it does pass our vertical line test. So passes vertical line test. Okay? Alright. So go ahead and try number 19 on your own. This will be the last one we do for today. Alright, so I'll go ahead and pause the video. So once again, guys, remember, these x and y values are just like ordered pairs. So this is your first ordered pair. So graph -8, -5, then graph -8, +3, and keep going until you are done graphing all your points. Once you have that, write down your domain and range values and tell me whether or not it is a function or not. And if it's not, tell me why it's not a function. Okay? So go ahead and pause the video and give these a try. Alright guys, so I'm just going to go ahead and finish up right here. Again, you don't have to do this. I like to do it because it shows me the ordered pairs, so I can go ahead and go straight to graphing them. So -8, -5, I'm right down here. So I went left 8 and left 5. I'm sorry, left 8 and down 5. Now -8, 3, I go left 8, but now I'm going to go up 3. -5, +4, so -5 means I go left 5 and then up 4, because I have a positive. Then 0, 2, so no shift to the left or right, but I do go up 2. And finally 8, -5, so +8, which means to the right, and then down 5. Alright, so just like before, let's go ahead and establish what our domain and range values are. So remember, we talked about how all of the x values were our domain values. So in set notation, let's go ahead and go from smallest to largest. So the smallest one I see here is a -8, and it actually repeats. So I'm actually only going to write it once. So -8, next one is -5, next one is 0, and finally 8. Okay, so -8, -5, 0, and 8. And remember to always put domain and range in set notation. Alright, finally for my range values, that's when I'm looking at all of my y values. So let me go ahead and highlight that. So again, same thing, from smallest to largest. So smallest here is -5. Again, we have a repeat, but it's okay. I'm just going to write it once. So -5. Next one is 2, 3, and finally 4. Okay, so we have, like before on the last problem, we have multiple ways of figuring out whether or not this is a function. You can either look at your table of values here, or you can actually tell me, according to this graph, whether or not it is a function. So right away, again, our criteria is if our x values have a repeating number, a repeating x value, then we do not have a function. Okay, in order to be a function, it has to have unique x values. So right away here, I notice I have 2 -8s in my x values, so automatically this is not a function. You can extend that answer by saying the relation has 2 -8 x values. Okay. Now finally, if you would like to, you can actually draw vertical lines here on all of these and verify whether or not it passes the vertical line test. So if you wanted to figure out if it was a function, you could also do it this way. So here, yes, it only hit once, so it passes. Here it only hits once, it passes. Here it hit once, it passes. But something happens right here, guys. In this exact same line, we actually hit 2 different points. Because we hit 2 different points, we actually have to trace them and show that in that vertical line we actually do not pass the vertical line test. So once again, if you wanted to write that here, you would say, whoops, sorry about that, you would write does not pass the vertical line test. Alright guys, I think that is it for today, so go ahead and stop the video now, or if you are still a little bit confused and want to relook at a few of these things, why don't you go ahead and pause the video and go back to the section that you didn't quite understand so you could take another quick glance at it. Alright guys, have a good one.